You start streaming the event? Yes, I am. Okay. So this week we're going to start off by talking about kind of giving you guys a nice introduction to Moto. Okay, and there's going to be a lot of interesting concepts that we have to wrap our heads around. In every sense, I have to reprogram your brains to think within inside that third dimension, and this is not going to be an easy task. Okay, all of us in here think in 2 dimensions, relatively easy, right? Every piece of artwork we've seen up until this very moment has been a 2-dimensional model or a 2-dimensional image. Well, I have to start getting you guys think within inside that third dimension, that depth dimension. In addition, the challenge is compounded by the fact that we're not painting, okay? We're physically building things. So we have to be part artist and part engineer, a unique challenge that makes us different from some of the other fine arts inside this community. So, please be patient with both the process and your own learning pace over the next couple of weeks. Okay. I mentioned last time we saw each other that there's going to be a steep learning curve over the next 3 or 4 weeks. This is the hardest part in this course, is fundamentally the reprogramming bit, where you start looking at these really weird environments with these really weird conceptual tools and start building these amazing shapes. Okay, so please hang out, be patient. We'll get there. You know, everyone will have that aha moment where you just kind of get it. So. Something to be looking forward to as we go through the next couple of weeks. As I mentioned last week, we're going to be studying, or we're going to be using a tool called Moto for 100% of the stuff that we're doing in this class. It's not because Moto is the best 3D modeling application on the market, and it kind of is, but that's not the only reason, okay? Moto provides you guys with an excellent opportunity to learn the basics in an environment that's not intimidating and harder than it needs to be. Moto is the perfect tool for beginners. It allows us to build shapes quickly, focus on the techniques and the tools and the larger picture ideas without having to wade through endless menus and confusing hoops and it's just some really weird computer science. It's a great app. In addition to being the perfect tool for beginners, it's also an industry standard app. It's being used all over the world to do these really fantastic pieces of artwork. I guarantee you've seen an image or a model or a render that has come out of the Motoverse. Guarantee you, if you've been to the Apple website, bam, you've seen something that's been made in Moto, as a majority of the images on the Apple website are models and renders that have come directly out of our application. How many guys went and saw Pacific Rim? Love Pacific Rim. All the art direction. The art department down at Industrial Light and Magic uses Moto for a majority of their work. Okay? How many guys went and saw WALL-E? All the robots in WALL-E were made in Moto. Okay? So it's a really cool application that's being used all over the place. I think most recently it's getting a lot of attention for its application in the games world, as Borderlands 2 was all done inside of Moto, which is kind of neat. So it's a great app. I've been working with Moto since its beginning. Truth be told, I started off working in an application called Maya, which is another great, phenomenal application in our world. And then I kind of stumbled upon Moto through a friend, and I immediately jumped ship. I mean, it was fantastic. For me, Moto represents the only 3D package that brings the initial joy and entertainment back to the process of 3D modeling. Come on in, just getting started. For those that enter late, you get a lot of attention from the entirety of the class. What's your name? Mackenzie. What's your last name? Fong. All right.
I was going to ask, do you have any permission letters left?
No, we're all full.
I missed last week.
Yeah, we're all full. Yep. Sorry. Yep. All right. Try again next semester. We offer it every semester. All right, so let's go ahead and get started with the Moto. It's I've placed all of the executable icon for Moto down in your dock. So if you're new to working on a Mac, that's the part down at the bottom of your screen. I have mine hidden at the moment, so let's just go check it out. So here it is. There's Moto, the big yellow circle with the black background. If you launch, huh? Sure, it could be a worm. If you want it to be a worm, it's a worm. You click on the icon, the application is going to launch in front of you. Here we go. And ignore these pop-ups. These are something that's specific for me. I have a couple plugins that are installed whose license just expired. So welcome to Moto. This is going to be your new home away from home. And specifically, let me change my screen to just match kind of what you're used to seeing. There we go. So this is what you're seeing in front of you. Moto is an industry standard 3D modeling, texturing, animation, rigging, simulation, and rendering application. It does the full gamut. We're back. Everything is here now. In the past few versions of Moto, there were certain features that were absent. Well, now they've rounded out the feature set, and it is complete. It has everything that you'll possibly need, and then some. They've thrown the kitchen sink at this bad boy.
My Moto is not responding.
Your Moto is not responding. Can you be a little bit more specific?
I'm clicking the icon and it is not.
Okay, just give it a second. Oh, wait, no, it's actually not doing anything at all.
It's not doing anything at all.
Yeah. Yeah, I'm going to right-click on it, and I'm going to guess that it's maybe because there's a bazillion apps open,
Okay.
including Bridge. You know, one of the challenges that we're all going to have to, kind of work around in this classroom is that this classroom is used by a number of other classes on campus, and those photography students, I love them, they're wonderful people, the instructors are my friends, but they leave all of the applications open at the end of the day, and it absolutely drives me crazy. So when you come into class, just look down at the dock at the bottom of your screen, and if you see a whole bunch of little dots below the icons, that means that application is open and running in the background. Just right-click on it, and just choose Quit from the little contextual menu that pops up. That will make the performance of your machines go a whole lot better. Okay? All right. So welcome to Moto. I apologize for a little portion of my screen hanging off over the edge here, but luckily that's part of the interface that is not critical for what we're going to be doing on a daily basis. Okay. So let's kind of take you on a little bit of a tour of the application. In essence, well, let me take a step back. All 3D modeling and animation applications can be a little intimidating, but there's a common denominators, or there are a couple common denominators between the applications that we need to draw focus to. The first one are the tools. Okay, we have a phenomenal toolbox available to us here in Moto. There are hundreds of tools that allow us to do some pretty amazing effects and to build some really cool models. You're going to find all of your tools, or at least the majority of your tools, on the left-hand portion of your screen. So specifically what I'm talking about here is all of this stuff, okay? These are all of your tools over here. And there's a bunch of them, okay? There's a whole bunch of them. The guys down at Luxology have done a great job of organizing the tools into a whole series of tabs. So if you look right here, you can see there's a whole bunch of vertical tabs. These are purely just collections of tools. If you read the name of all those tabs, you'll start to get a better idea of which tools are going to be found in each one of those little collections. So they've organized it a little bit logically to make it easy to find the tool that you need in that moment. So if you need to change something on your mesh, you're probably going to go into the Mesh Edit series of tools. If you're going to be creating a basic shape, like a box or a sphere, the Basic Tool tab is going to be home to all of the basic construction tools that you'll need to make the shapes that will eventually turn into some really cool 3D models. We're not going to go through all of these tools, but just know that the left-hand portion of the interface is where we're going to find all of our tools. Okay. All right, so this is going to be our tool section over here on the left-hand side. Woo! Okay, that's all tools. Now here in the center, this is actually a really important part. This section right in here, all of this stuff, is a really important part for us in the Moto world, as this is where we're going to be doing the lion's share of our work. The center part of our interface is home to what's called the OpenGL viewport. In every sense, this is a window into our true three-dimensional scene. Now, I know that we're just getting started here, so please bear with me. I want you guys to just add something into your scene. So I know everyone's sitting in front of a machine here. I want to place an object in the center of my three-dimensional universe. That way we have something to play with over the next couple of minutes. So go to the top of your screen where it says Geometry. And then from this crazy pull-down list, I want you to go to Unit Primitives, in Current Mesh, and at the bottom of that list, there's going to be an option that says Teapot, and just click on it, okay? And on my screen, there's a teapot way in the center. We'll get back to that here in a minute. At least we have something to play with now as we start to explore all these wonderful, wonderful features of the application. If you don't have a teapot, just hit the A key on your keyboard. All right, I'll do the same, just to kind of zoom in a little bit. Boop, there it is. All right. Okay, so let's take a look at how we're going to be interfacing with all of our models, and specifically our three-dimensional scene. the center part of our interface has a whole series of tools and options, some of which are really important, others are not so critically important. Let's talk for a second just how we can orbit and navigate and look at our scene from a number of different perspectives. Okay? Working inside of Moto, or any 3D modeling application for that matter, is going to require you to have one hand on the keyboard and the other hand on the mouse. So if you're very adverse to the idea of having one hand on the mouse and one hand on the keyboard, you have to get out of that fear right now. Working this application requires one hand on the mouse, one hand on the keyboard. Okay? With one hand on each one of those, we can start to manipulate the basic keyboard functions that will allow us to do a number of really cool viewport actions. Okay? I want to be able to rotate around my teapot like this. This is called orbiting. Now, we're not actually rotating the teapot. It's stationary. It's not moving. We're moving our perspective within inside that scene around in a circle. So imagine in the center of the room, there's a gigantic teapot. It's stationary, and my eyeballs are rotating and moving around that teapot. In order to do the orbit function, we have to hold down the left mouse button in combination with the Option key. So the Option left mouse button is going to allow you to perform the orbit function. Get to rotate around just like this, okay? Now, what if I want to pan my scene? So move my scene left and right, as I'm doing here. I'm not rotating now. I'm physically moving my perspective within our three-dimensional scene left and right. To do that, we hold down the Option, Shift, and then left mouse button drag. Okay? Option, Shift. Option, Shift. That's going to allow you to pan. Everyone just pan around for a second. Take a couple minutes, an opportunity, if you will, just to get this into your own personal kind of muscle memory. Spend 10 minutes, get comfortable with it. You want to be so comfortable with these keyboard shortcuts that you don't have to think about navigating around in your scene. You want it to be just second nature. So just take a minute. Everyone just do it real fast. Get comfy with it. Yeah. For what? Option Shift for pan. Option left mouse button and drag for orbit. All right, looks like everyone's kind of getting it. Now the third one that we have is the ability to zoom in and zoom out like this. Zoom in and zoom out. So we can get all up in there and get close, or zoom out. The keyboard modifiers for that action is Option Control in combination with holding down the left mouse button and dragging. Now you're holding down the Command key, Leland. Yeah, okay. Just want to make sure you knew. Slightly different action. All right. Get comfortable with it. Get comfortable. The goal of today is to kind of shake off all the fear of working inside these apps, because they are a little intimidating, but once we kind of get to understand how to work with the basic navigation tools, it becomes a whole lot easier. Yeah? All right, let's take a look. All right. So here's what we're going to do. Just going to go layout, and we're going to go to tabbed. There we go. And add that geometry in, that teapot, and we'll be on our way. All right. All right, all right. So as a review, Option left mouse button, what does that allow you to do? Rotate, also known as the orbit, okay? Option Shift, this, what's that allow you to do? Pan, you got it. And last but not least, what's the zoom? You got it. Option Control. Option Control. Zoom in and zoom out. Now there's a couple other ways that we can quickly navigate around our scene. We don't necessarily have to use all of those lovely keyboard modifiers. For example, a number of you guys were caught in a little bit of an interesting situation when we first added that teapot. The computer, or your perspective on the scene, was way out over here like this, and the teapot was infinitesimally small, right? Hitting the A key will automatically fit the contents of your scene inside the OpenGL viewport. So if you can't see your stuff, just hit the A key like this. Whoop, and boom, there it is, and we're on our way. Pretty neat. Yes, sir. Absolutely. Absolutely. So if we're all up in there, right? If we're inside the teapot, okay? So I'm inside the teapot right now. Oops. Okay, I'm inside the teapot. If I hit the A key, boom, pops it out. All right, great way to very quickly find your stuff. Now, all of our content is going to be placed at a very specific location within inside of our three-dimensional scene, okay? I always tell people that when we're first starting out working in Moto, it's like we're working inside of, some sort of three-dimensional universe, okay? Imagine that the center, or let's take a step back. Imagine that the center of our universe, or that we're participating, in our solar system. We're hanging out in our solar system, right? Everywhere we look, we see stars. Where's the center of our solar system? What's the center of our solar system?
The sun?
The sun, absolutely. We also have a defined center point in our little three-dimensional scene. This is a very important element. I'm going to turn off the visibility of my teapot just momentarily so you guys can see what this looks like. Okay. Can you see on my little grid here, those two black lines? I know it's a little bit difficult to see in the projector. Let me help you out a little bit. I'll draw them. You'll see this on yours. So there's a black line that goes right there. A black line that goes right there. Okay? At the intersection of those two black lines on your grid is a critical, important element inside of our three-dimensional scene. Does anyone know what this is called? The zero axis, okay. Yes, that's it. There's a very specific term for it. It's the intersection of the x and z axes. Absolutely. Actually, it's the intersection of all three, okay. It's called the origin. The origin is an important element because it is the intersection of all three of the axes that we're going to be building our objects within. Now, if you really think about it, we're going back to high school geometry. So I want you to go into the Wayback Machine. Some it's further back in the Wayback Machine than others in this classroom, but go back to high school geometry. In high school geometry, for a majority part of your career there, you were plotting points along two axes. Which were those two axes? The x and y. How would you describe the location or the role of the x-axis? What did it look like? Plotting points. Was it up and down or was it left and right? Yeah, horizontal, it's left and right. The x-axis is always going to represent the horizontal axis, okay? So the x-axis, we got the x-axis, which is, I'm going to just put left and right, horizontal, okay? What's the y-axis? Vertical, absolutely. So the x is left and right. The y-axis represents plotting points along the vertical, and I'll just put up and down. Which brings us to the last one, which is the mystery for a lot of people. How would you describe the role of the z-axis? Front to back, absolutely. Absolutely, it's front and back. Forwards and backwards. So I'll just put that on the board too. So it's front and back, okay? So these are the three that we have to work with, the x, the y, and the z. Now, go back to high school geometry. When you were plotting points along the x and the y axis, did they have a center point? 0, 0. Right, absolutely. We're doing the exact same thing in the three-dimensional world. We're still working off this idea of a 2D Cartesian grid. All three of our axes have numbers associated with them. The absolute center of all three of those axes is represented by those two, well, I guess it's getting kind of a little bit muddy now, but those intersection of all of those lines on the screen, okay? That's the center of our universe. That is 0, 0, 0 on all three of our axes. This is the most important landmark inside of our three-dimensional scene. It's like the sun. It's the center of our solar system. Why would you imagine that the center of our scene is important? What's the big dealio? It's the starting point. I like it.
So everything becomes symmetry when you center
Yeah, absolutely. If we're modeling a character, for example, we want the left half of our character to be identical to the right half of our character, right? We would like to be able to model within symmetry. If we're centered around the origin of our scene, the center of our universe, we'll be able to do that easily, much more easily. The origin of our scene is a landmark. It's the only landmark within our entire three-dimensional scene. It's defined by the location of those, the intersection of those two black lines on the grid. It's the only landmark we get. So it's a good reference for where our objects are. There are very few things that are industry standard inside the 3D modeling and animation industry. The idea of an origin is, if I was to send a model that I made here in Moto over into Maya or over into our game engine in Unity, it would show up where? At the origin of their scenes. So it truly is the common denominator between all the different 3D modeling and animation packages. I'm a little old school when it comes to my 3D modeling practice. I truly and fundamentally believe that if you're not modeling at the origin, you are modeling wrong, okay? We want to model all of our objects at the center of our scene. Yes, sir?
And also, if you're developing games and you have a model at the origin, then when you're putting it into your game, if you're just programming it in, it's easier when it's at the origin, because otherwise it could be way out anywhere.
You got it. It could be just, our three-dimensional scene is infinite. There are no borders to the playground that we're building our objects within. So it's important that everything be placed at the origin so we know where to look for it, right? In addition, I'll get to you, I see your hand. In addition, we often, as 3D modelers, hand our scenes over to animators, or we'll hand our stuff over to a layout artist or to our character rigger. They're going to expect and demand that all of our stuff be centered at the origin of the scene so they can take it and start doing their thing with it, go on to the next stage in the production pipeline. If it's not at the origin of the scene, well, where is it? You know, they're going to have to go find it, and people who, you know, if it's not at the origin of the scene, they'll get grumpy pretty fast, because then they're going to spend more time looking for your stuff than working with it, okay? Huge problems. Yeah, absolutely. Absolutely. Yeah, this is a critical idea when we get to the rigging portion of this class, when pivot points and center points for our objects are going to absolutely determine how our characters bend and deform in a real-time fashion. Okay? It's a critical place inside of our scene. It's the most important landmark. In addition, if we model everything to the origin, we're also going to get access to a whole series of tools that will ultimately make our lives as 3D modelers a whole lot easier. In addition to us knowing that the origin is the center of the universe, the computer, the application also knows that the origin is the center of the universe, and it gives us access to some really neat tools like mirroring and symmetry, and being able to work at a much finer level of detail on the vertex side of things. So it's a critical idea. We're going to be working with the origin almost exclusively in this class, and you're going to see me building everything at the origin of my scene. Questions on that? Kind of make sense? All right, the origin. Gotta love the origin. Okay. Now, the guys down at Luxology have done a really great job of reminding us and telling us the orientation of all three of our axes. Okay. Inside the OpenGL viewport, you're going to see this grid. Now, this grid is going to change a little bit as you magnify in and out of your scene. But at the corners of each side of the grid, they're always going to tell us the orientation of the axes. And I know it's very hard to see, but it's going to be darn near impossible to see on my screen because my stuff's so small. But at the borders of the grid, you're going to see little letters. Those letters represent the direction of each one of those axes. Now, this is where it gets a little weird, okay? We're working inside of a true three-dimensional space here. I got my teapot chilling at the center of my scene. What's the center of the scene called? The origin. The origin, the origin, the origin. Okay. How do I know which way's up? It's always going to be Y. Y always represents the vertical axis. But which way is up? Yeah, absolutely. The orientation of these axes within our three-dimensional scene is going to determine up and down. For example, let me bring my teapot back. and start looking at this. I think I saw a question. Yeah, go ahead, James. Negative. The origin point in Moto is the intersection of those two dark lines. Yeah. Okay. Let me bring my teapot back here. There it is. All right, so, whoops, excuse me. All right, there's my teapot. Now, let's pretend I'm cruising around, and I do something like this, okay? Which is the top part of my teapot? Which is the top of the teapot? Visually, what's the top of the teapot? The bottom. What would be the bottom part of the teapot right now? A little nub at the bottom. In actuality, this is the top of the teapot, but I've orientated my three-dimensional scene to be looking at my teapot kind of upside down, right? So how do I know which way's up? By the axes, okay? In the lower left-hand corner of our OpenGL viewport, we have a critical piece of UI. It's this little thing. That's the compass, okay? Now this compass is going to continue to orbit around and move as we work with inside of our three-dimensional scene, okay? So let me just get a little bit easier to see there. That's the compass. Now the compass is comprised up of 4 major elements. Now please bear with me. I do apologize. This is going to be a horrible illustration, but I will try my best. This is what the compass looks like for the majority of it, okay? Y, X, and Z. Okay. There's a bigger version of the compass. This thing is going to tumble and move as we navigate around our three-dimensional scene. What do you think each one of the lines within inside of our compass represents? They represent the axis, okay, absolutely. So you get an indication as to where in the orientation of the Y, the X, and the Z axes are. And then most importantly, these are kind of, in my mind, these lines are like arrows, okay? So start picturing them as arrows, okay? Because they kind of point towards the positive direction of all of these axes, okay? So they're like little arrows. Just like that, okay? Little arrows, okay? These arrows are always going to remind us of the landmarks and the orientation of our scene itself, because the positive direction of the y-axis is always which kind of direction? I mentioned it before. It's up. Yeah, the y-axis represents up, but the positive values of the y-axis is up, right? And the negative values of the y-axis represent down, okay? Remember, we're plotting points along a grid here. So in every sense, what we have is an extension of our grid going this way. Okay? These are all the positive values over here, and oops, excuse me, that was supposed to be a plus, not an X, okay? And over here, these are all the negative values for that corresponding axis. We need to kind of wrangle the positive. We always need to make sure our brain is fixed on the positive orientation of all of these axes, because positive y values always represent the top side of our scene, right? So the negative y values represent what? The bottom side of our scene, okay? Pretty cool. Now, left and right can get a little bit kind of conceptual, because is it my left or is it your left? You know, is it the object's left and right, or is it the user's perceived left and right? And there are some schools of thought that demand and kind of dictate the left and right, the X value. But the two that we have to manage are positive Y and positive Z. Positive Z is another incredibly important orientation inside of our three-dimensional scene. So let's take a step back. Positive Y represent which part of our scene? Up, the top part, right? So what does positive Z represent? The front. That's the front of our scene, okay? That's the front of our scene. And the inverse of that would be negative Z is what? The back. Which direction, if I'm modeling a three-dimensional character, which direction do I want my three-dimensional model to be facing? The front, positive Z. I want his head pointed towards the positive Y, because that's up. And I want his nose facing positive Z, towards the front of our scene. Okay? Kind of making sense? These axes are really important. We got to kind of keep our eyeballs on these axes. Now, the guys down at Luxology have done us a solid. Yeah?
So does that mean the teapot in actuality is turned?
Yeah, the spout is not actually facing positive Z in this particular situation. It's facing which direction? Negative Z. How do you know that?
It's the opposite.
It's the opposite. But visually, how do you know that the spout is facing negative Z?
On the opposite side of the handle.
Yeah, of the compass. Check out the compass, right? This line is like an arrow, right? It's pointing towards the positive direction of the Z-axis. The arrow is facing the opposite direction of the spout. So we can deduce that the spout is facing negative Z. Yeah?
Also, could you rotate the model completely to turn it to the right side?
Absolutely. We're going to come back to that in a minute. But yes, absolutely, for sure. For sure.
This floating grid thing, that's supposed to represent the y-axis, and if so, why is it on the...
Yeah, James has stumbled upon something that we're going to talk about a little bit later. But I'll go ahead and just talk about it real fast. That little gray grid that you're seeing inside of our scene. Now, for me, the gray grid is currently, the gray grid is currently going this way. Okay? It's kind of hard to see on the projector, which is why I'm drawing the lines, okay? That light gray grid is something that's special, and for me, it's something that I can no longer live without inside of my modeling process. It's something that's unique to Moto. It's called the work plane, and the work plane is nothing more than an interactive snapping grid, which is why it changes its orientation based on your perspective inside of our three-dimensional scene. If you look very, very carefully right now, my work plane is cutting through the XY axis. However, if I change my perspective within the scene, the work plane is going to change its orientation. It snaps to a different axis. Right now, it's along the XZ. That's what this little white, light gray square in the compass represents, the orientation of the work plane. This is an important Moto element, and we're going to talk a lot about the work plane over the next couple of hours because it's amazing. It has changed the way I model. Okay, it's great. So we'll come back to that. All right. One other thing about the orientation of the XY axes, the guys down at Luxology have done us a solid. They know that oftentimes navigating and manipulating our three-dimensional scene can be a little bit of a challenge. They've given us a subtle, kind of subconscious reminder of the positive and negative orientation of the Y-axis. Has anyone picked up on it yet? Pop quiz. Based on what you can see on my screen, yeah, those little letters around the grid, another fantastic visual reminder as to the direction of all the values. Based on what you can see from my compass, which direction is the y-axis, the positive y-axis, excuse me? Towards the top, right? Because remember, each one of these lines is kind of like an arrow. It's pointing towards the positive values of the y-axis. And right now, that arrow is pointing up, okay? In addition, the guys down at Luxology have given us another reminder of the positive and negative direction of the y-axis. Has anyone picked up on it? It's subtle. It's there. It's on every single one of your screens.
It's the little thing in the corner, right?
Not that. That's the compass. In addition to the compass, Richard's got it. The gradient in the background is a subtle reminder of the orientation of the y-axis. It's lighter on top, kind of representing the sky, with a short little gradient transition in the middle, kind of representing the horizon line, and then it gets dark, the dirt, the ground below. So if you find yourself in an environment, if you find yourself in a situation where you're looking at something in your teapot like this, and you see a whole bunch of light pixels, if it's all light gray down here at the bottom, are we right side up or upside down? We are upside down. We need to flip our perspective over with the orbit command and get us back to where we need to be. Absolutely. Absolutely.
So you could make the world, not just the model, you could make the world so your model can interact.
We're gonna take this one step further to kind of illustrate this. Let's put something obvious. How about this one? And then I can actually change the way my background is drawn. There we go. If I wanted to. You know, I don't necessarily have to model the sky. I can import a photograph and have that placed in the background of my scene so I get a further kind of visual as to where I need to be. Okay? Pretty cool. We're going to go over that in the coming weeks. I don't want to inundate you guys with a lot of stuff today. All right. Other questions before we move on? So we've talked about working inside of our three-dimensional scene. We've talked about the role of the X, Y, and Z axes. Yes, sir?
I think someone might have changed the settings for this snapping. Call it the snapping. It doesn't snap to y-axis. The axis, it snaps off.
That's fine. Don't worry about it. That's actually what it's supposed to be doing. Yeah. Okay. So let's talk about how we can do stuff inside of Moto, because we've just been focusing on how to work within the scene. Well, I want to do something within the scene. It's not 3D modeling is more than just looking at stuff, right? I want to build something. Okay. Moto has a workflow that begins and ends with a selection. We have to tell the computer precisely which objects within our scene that we would like the computer to manipulate. So everything begins and ends with a selection, okay? How many of you guys have worked with Photoshop before? Photoshop, oh good, almost everyone in here is a Photoshop user to some degree, and if you're not, don't worry about it, okay? Photoshop also has this exact same idea, right? If we wanted to manipulate just one little portion of the screen, we'd go grab the selection tool, select the portion we want to edit, and then do our stuff, right? Well, we're doing the exact same thing here in Moto, and I'm kind of actually very thrilled that the crew down at Luxology has tapped into an existing kind of paradigm and have mirrored the selection system in Moto to what you see in Photoshop. Before we can talk about how to select stuff, we probably should spend some time talking about what we're going to select. The basic building blocks of all 3D models, okay? We have two different layers, two different hierarchies, if you will, that we have to work within inside of any three-dimensional modeling application. At the topmost layer of that hierarchy, so think of these hierarchies kind of like containers, okay? At the topmost layer of that hierarchy, we have something called an item. Something called an item. The item is a container. It's a folder. It's a bucket that's full of stuff, okay? When I manipulate the item, I get to control and move or rotate or scale everything that's inside that bucket. Okay? The items that we have available to us over in our scene are communicated to us over here in what's called the item list. And right now, every single one of us has 3 items in our scene. Now I have 4 because I added that cool little environment that I was showing you earlier, but you guys have 3. One that's called mesh, one that's called camera, and one that's called directional light. These are items, okay? Now, the one that I want to focus on today is the mesh item. The mesh item is a really important container for us in the 3D modeling biz, as this is the only container that's going to contain our model, okay? These are where all our vertices, edges, and polygons are going to exist. Manipulating our items is really, really easy. Let me show you how we do it. At the top of our screen, and I apologize, let me just kind of zoom in momentarily. At the top of our screen here, right above our OpenGL viewport, we have a number of selection sets. Way over there on the right-hand side, you can see a button that says Item, keyboard shortcut number 5, and that's the number keys on the top row of your keyboard, not the number pad, okay? So if I was to change the system my selection system inside of Moto, I can change and manipulate the contents of my teapot item. So I'll just go there, I'll click on it with my left mouse button. Here we go. And now, check it out. If I was to left mouse button on my teapot, the entirety of that teapot goes orange. Okay. We're now controlling everything on that item. All the spout, the handle, the base of the teapot, everything is in that one bucket, which is pretty cool. Okay, so I get to control the entirety of the contents. Now over here in our toolbar, let's do something with our item. These are our transform tools, these three guys. They're really important, okay? You're going to love working with inside the transform tools. Okay, there are three. There's the move tool, there's rotate, and then there's scale. Okay, this is this one right here. Oops. Move, rotate, and scale. There's three industry standard keyboard shortcuts that I would like you guys to start committing to memory for move, rotate, and scale. It's pretty easy. The move tool, and this is something that you see in every app, which I'm very thankful for. The move tool, its keyboard shortcut is W. W. Yes, sir, go ahead.
Mine doesn't have it.
Yours doesn't have it.
Well, mine's not showing
Showing what?
the tool for some reason.
Ah, someone's been messing around. So here's what I want you to do. Go to the top of the screen where it says Layout, and go into Layouts. Keep cruising down. There we go. And then just click on Model. There we go. You're welcome. All right. So keyboard shortcut for the Move tool is W. Steve, yeah. Hit the 4 key on your number pad. Number pad, yeah. That help? No. Okay. Someone's changed yours into topology mode. Put your mouse cursor in the center of the scene. Hit the O key.
O key?
Yeah. And what we need to do is go turn off topology mode. There you go. Okay. All right. So the Move tool. Let's zoom out and take a look at what the Move tool is all about. It's a pretty neat little tool. As you would imagine, the Move tool is going to allow us to move our objects. So you can either hit the button over here. That's just dandy. Okay. Or you can use the keyboard shortcut, which is W. Whenever you activate any tool inside of Moto, 9.9 times out of 10, you're going to get a series of action handles that will allow you to manipulate that tool in conjunction with whatever it is that you have selected. I got the teapot selected, so what do you think I'm going to move? I'm going to move the teapot. You got it. There are 3 basic handles on the Move tool. So if you drag on any one of those handles, you're going to constrain the Move tool to only moving that object along that axis. So if I wanted to move my teapot along the Z-axis, which one of those tools or which one of those handles am I going to move? Look at the compass. It's the blue one. I'm going to let you in on a little bit of a secret here. There's actually, we've standardized around a couple colors, okay? If you look very carefully, at the compass, the tool handles, there are some uniform colors that represent each axis. What are they? What color represents the x-axis? Red. You got it. Everything corresponding to the x-axis is going to be labeled as red. What's the y? Green. Y is always going to be green. And Z? Blue. You got it. The faster you guys remember this, and the easier working with all these tools will be. Yeah. Color circles. Yeah, those colored circles are kind of cool. Let me clear my board here. The colored circles are kind of cool. So as a reminder, just grabbing any one of these handles will allow you to move that object only along that specific direction. Now, it's kind of a good habit to grab the arrows. You can work the tool, and I probably shouldn't even tell you this. You can work the tool by clicking off of it and doing something like this. This is dangerous, okay? Because you don't know which direction you're moving your object within. This is very, very dangerous. This is bad technique. Do not do it. Only manipulate the handles, okay? We kind of have to be control freaks to a certain degree as 3D modelers. We do. We need to be able to manipulate our objects with accuracy, because if we don't, you're going to screw something up, okay? This is a professional 3D modeling and animation package. They don't pull any punches, okay? They're not going to help you. They're expecting that you guys are skilled operators, okay? And only you can prevent forest fires, okay? You know, it's one of those things where if you move it to some place on your scene and you don't recognize and realize where it has gone, I don't know where it is either. I mean, it's gone. You have to kind of manage it. Yeah.
Okay, so they have an undo tool, but is there a step backward tool?
No, undo, that's the only thing that we have is undo. Yeah.
It's easier, like if you're moving things and you don't know where they are, you can always look for the position. So it'll show the numbers, the actual numbers.
Absolutely. Using the options, we're going to come back to these tool options here momentarily. Okay, so the last thing that Ryu kind of drew focus on, he saw, you know, it's kind of hard to see. There we go. Zoom out, you can see them. Do you guys see those little circles? These guys? These are called coplanar handles. If you were to click and drag on those coplanar handles, you'll only move this object along 2 of the 3 axes, okay? And the way I always remember which axes I'm moving my object along is to look at the color of the coplanar handle and then subtract that axis from the movement that you're about to do. So if I was to click on the green handle, I would know that I will not be moving this thing up and down at all on the coplanar handle. If I was to click on the red handle, the red circle, I apologize. If I clicked on the red circle, I'll be moving that teapot along which 2 axes? Up and down. So the y-axis and what other one? Yeah, the Z, the green and the blue one. Okay, that's how I remember it. If I click on the red, that's the axis that I'm not going to be manipulating this object along. Okay, so if I was to click on the blue one, which axes will I be manipulating this object along? X and Y, right? Because we're subtracting that axis from the move tool. Okay. All right. Okay. So the move tool. Have fun with the move tool. Okay. Woo. Of course. We also have the rotation tool, which is this guy right here. Now, when you rotate our objects, hold on a sec. Help if I select something. There we go. You're going to get these little circles. Very similar in kind of form and function to the move tool. If I wanted to rotate my object along a very particular axis, grabbing that color axis will allow me to do so. Pretty neat. And this is another one of those things where you don't want to just click off the model and then left click and drag. This is danger, danger, danger. Okay, because now you don't know which axes you're rotating this along and at which percentage. E. Yeah, the keyboard shortcut for rotation is the E key. And finally, let's just do the scale, which is the last one there. Keyboard shortcut is R. Okay, and that will allow us to make our teapot bigger or smaller. A couple things about the scale tool that's important to point out. Clearly, we have action handles that will allow us to scale it along individual axes. Okay, so if I wanted to make it like a football, I see your hand, Randall. If I wanted to do something like that, I can just scale it along a particular axis, which is kind of neat. But if I wanted to scale it uniformly along all 3 axes, so globally make it bigger or globally make it smaller, it gets a little bit tricky, okay? It's difficult to see on my screen because of the projector. It'll be easier to see on yours. But right smack dab, oops, wrong one. Right smack dab in the middle of our tool handle is a light blue circle. If we left click and drag on the interior of that light blue circle, we'll uniformly scale that object up and down, bigger or smaller. Okay? Let me show you what I'm talking about here. So click on the center. It actually goes into a nice little yellow color when you're hovering right on it. And we can uniformly scale that object along the X, Y, and Z simultaneously. Pretty cool. So the W key is move. The E key is rotate. And the R key is scale. I wish it was Talk Like a Pirate Day. You guys know that we actually have a Talk Like a Pirate Day? I love Talk Like a Pirate Day. It's great. Gives me an excuse to say R a lot. And me hearty. Things like that. Anyways, I'm geeking in. Okay, questions on the move, rotate, and scale tool. You'll be doing this a lot. Yes, sir?
After you rotate something, can you freeze the transform?
Can you say it again?
Can you freeze? Do you know how to freeze transform?
We don't have that. We don't have object history or tool history like we have over in... so we don't have tool history, but we also do have... We can freeze the transforms. That's something that's over here. Okay? So we can reset the home of that object to 0, 0, 0 and to all that stuff if we want. So we don't need to delete the history and freeze the transformations like you're often doing over in mine. Say again? I can't hear you. Reset? You can't. Oh, actually on item level you can, but on the other ones you can't. We'll talk about that difference in a minute.
So can I press one of the positions and actually put in the number specifically that I want?
On item level, you can. When you're working at the item level, you preserve all of your transform information. If you look carefully over here, the computer's logged all the movements that I've done to that item. You can see that it's no longer sitting at 0, 0, 0 on the XYZ axis, and I've also scaled it to a value of 79% along all three of our axes. Okay, we get access to this information when working at the item level. Okay. Item level, because what we are doing here is that we're working on the entirety of the container and all that stuff is saved. So if we wanted to, and this I think answers your question, you can reset your item. Okay, there's an option here. It says reset, and you can reset your position, scale, and rotation values whenever you want. So for example, if I wanted to get my teapot back to its original size, I can reset scale, and it goes back to 100. I can also reset my position, and it's going to go back to the origin of the scene itself. Okay? I don't want you to focus on that almost at all in this course. That's something that you're going to be spending a lot of time in and understanding when you get to GCOM 410. We're going to be doing a majority of our 3D modeling at the component level, at the vertices, edges, and polygon level, which is going to be a whole lot easier for you guys to work with. Yeah? Comment? Question? Good. James, yeah?
Yeah, you said you did something to snap back to the origin point. What did you do?
So I selected the item from the item list. And down here in the Properties panel, there's an option called Reset. And you can just choose Position from that contextual menu that pops up. All right. So what if I wanted to go in and move just the spout? I don't want to move the base of my teapot. I don't want to move the handle. I just want to go in and manipulate the spout of my teapot. Interesting idea, right? Yes, sir?
You could just use the right mouse circle.
But at the item level, we're controlling the entirety of that mesh item, right? What do we need to do? Nope. We need to work down our hierarchy. Remember earlier I mentioned that we're working within a hierarchy of different elements inside of our three-dimensional scene. The item is, of course, the topmost element. So oops, what am I doing here? So pretend that's an I. Item, okay? We've been working at the item level up until now. We've been moving the entirety of my teapot. Now I just want to go in and move the details of the spout. I don't want to mess around with the base or the handle. Okay, I just want to grab the spout. This requires us to go down a level, okay, and start working with the building blocks of all 3D models, okay? And there are 3 of them. Does anyone know what the 3 building blocks, the 3 component types are?
The polygons, edges, and vertices.
You got it. So the three components of all 3D models, we have polygons, edges, and vertices, or vertexes. You know, vertex is the singular, vertices is the plural, vertices. Okay. These are the building blocks. These are the building blocks. Let's take a step back and find an example that will help you guys kind of decode what it is that we're trying to accomplish here. The item is kind of like the car, right? It's like a car. What is a car made up of? Hundreds of individual little pieces, right? You got the tires, you got the engine, the transmission, the radiator, spark plugs, steering wheels, hopefully an awesome stereo. A whole bunch of little things create a car. But at the end of the day, you don't go drive your engine, right? You go drive your car. The car is like the item. But there are times when you're going to have to go move the engine, right? Maybe to repair it or change the tires. And you'll have to start working on those individual pieces. The items, like the car. Polygons, edges, and vertices are like the tires, spark plugs, and radiators. Okay? So the basic building blocks. You put all those pieces together, you put all the components together, and you have an item. Okay? We get to control everything or individual components separately from the rest of the model. Okay? Item level and then component level. We've been working at the item level up until now, and as I mentioned earlier, it's time for us to start working at the component level. So if we go back to the selection set menu at the top of the screen, you'll kind of probably have already started to kind of take a guess as to where we're going. Vertices, edges, and polygons. By selecting any one of those three buttons, we can select and manipulate any of those component types. Let's define what these component types are, so at least you have an understanding of the vocabulary, of the vernacular. Let's start with the vertice. Keyboard shortcut number 1 on the top row of your keyboard. Okay? And I'm going to orbit a little bit here to the top of my teapot. And I'm going to do some fancy things here so you guys can see what's going on. Okay. You see all those little black dots? See these little black dots? They're everywhere on our mesh. Okay? Those are vertices. A vertice is nothing more than a point. It's a single point. That's all it is. It's a dot. But it's a special dot. The computer knows precisely where this dot is. It understands the location of all of these dots in the scene. It's one of the things that it's kind of managing on the back end of the application. When I'm in my vertex selection set, I can very easily go in and just left click on any one of these vertices. Boom, and it turns orange. Orange, by the way, is the selection color inside of Moto. So if something's orange, that means you selected it. By itself, a vertex is just a vertex. It's just a dot. It's a three-dimensional dot floating in space. That's it. It's almost kind of meaningless on the modeling stage. When we start working with particles in 410, vertices take on a whole new role. That's actually a really neat role, okay? But right now, a vertex is kind of meaningless. So let's make it meaningful. If you go back into your 10th grade geometry, you actually kind of explored this idea of plotting single points along a 2D Cartesian grid. Now, when you combined a vertice, when you connected two vertices together, what did you create? A line, right? Well, that line in the Moto world is called an edge. Okay? You connect two verts together, and you have what's called an edge. So I want to change my selection set at the top of the screen to edges. And now I can select an edge. And there are edges all over our model. FYI, check it out, when I hover above any sort of 3D component, it's always going to turn light blue. This is the selection, this is the rollover highlight. So it kind of gives you a preview of what you would select if you were to left click right now. So I can click on it, it's going to turn orange. Okay? So one vertex by itself is kind of meaningless. You combine it, you connect it with another vertex, you now have an edge. What happens when we combine or connect three vertices together? You get your first surface type, which is called Triangle, okay? And at the top of our teapot, we have a whole bunch of triangles. So if you were just to kind of think about it real quickly here, we have one. So we have one vertex, 2, 3, okay? And in between them, we have edges. Okay? This in here is our first surface type. This is called a triangle, okay? Now, all surfaces can be selected if we were to enter into the polygonal selection set. So that's the third one up there in our selection set menu at the top of the screen. So if I'm going to hit the number 3 key and grab polygons, and there it is. We're selecting a triangle. A triangle. So one vertex is just a point in space. 2 connected to each other forms an edge. 3 connected to each other forms a triangle. And then 4 connected to each other forms what we call a quad polygon, a 4-sided surface, a quad polygon. This is the most important surface type in our modeling tool set. We should always be striving to create our models in quad polygons, as they give us the most flexibility going forward, okay? A lot of game engines require all of our objects to be triangles, and that's purely a limitation of the graphics cards that are in all of our machines, okay? The NVIDIA and ATI have spent billions and billions of research dollars making it very, very easy for those pieces of hardware to do the math on a 3-sided surface, okay? It's not because they're the best, it's just because that's what the graphics cards support. If you think about it, it's a whole lot easier for the thinking machine on those graphics cards to figure out a surface that's made of 3 vertices versus 4. It's just physically less math, okay? It's less information that the computer has to keep in its onboard memory, okay? We want quad polygons. Yes, sir?
And how do you convert them all to triangles? That way if you can make a game.
Super easy. And this is why quad polygons are the gold standard. Ultimately, we want to have quad polygons on everything because I can transform a quad polygon like I have here in the center into a triangle really, really easy, right? Does anyone know? That's the keyboard shortcut, but philosophically, all we're trying to do here is just draw a diagonal line within the quad polygon, and now I've created 2 triangles, okay, in that surface. So they're the most flexible. Quad polygons are always, always, always the goal because they give us options, okay? Our rendering engine also loves quad polygons. That's not to say that if you fed it a triangle, it would do poorly. That's not the case at all. But there are some really fancy technologies inside the Moto rendering world that makes quad polygons definitely the route to go, okay? They're also universal. I can send this model to any application on the planet, and it will be opened, okay? And we'll be able to manipulate that model in another app like Cinema 4D or Houdini or Maya or 3D Studio Max. In addition, towards the end of the semester, we're going to start talking about mesh sculpting as we enter into the character world. The sculpting engine inside of Moto prefers and gives you a better result if it's all quad polygons, okay? So there's a lot of really good reasons to build our meshes entirely in quads. No. Yeah, it's kind of the cool thing about working in Moto. So once you generate those UVs, any sort of edit to those UVs or any edit to the mesh will automatically be adopted on the UVs. It's great. It's pretty cool. Okay, that's not the quad polygon is not actually the last surface type that we have access to here in Moto. We actually have one more. It's called an n-gon. And an n-gon is nothing more than a surface that has more than 5 points. I've just drawn an n-gon real fast using a tool called the pen tool. And there it is. There's my n-gon. And if you look at it, we have 1, 2, 3, 4, 5, 6, 7 vertices that all form and create that one surface. Now, n-gons are a relatively new surface type that have popped up maybe within the last 5 years. There are very few applications that support, on the rendering side, n-gons. Moto is one of them. Other apps, not so much. They force you to have quad polygons in order or triangles. So you can create n-gons, but it's not something that I would encourage you to do. At the very least, you'll have to edit that n-gon into a quad polygon shape at the end of the day.
What would be better about having an n-gon versus any other shape?
N-gons allow us to flush out shapes quickly without having to worry about a quad, by making it into a square. Like for example, you'll see this in action when we start working with our cell phone. Okay, a lot of times the buttons of cell phones, they're not squares, right? They're kind of unique, odd shapes, maybe something like that. The pen tool allows me to kind of sketch out that shape quickly without too much fuss and fuss. Okay, there it is. Let's see, I got, how many polygons I got here? I got 1, 2, 3, 4, 5, 6, 7. 7 different polygons, or 7 different vertices on this one surface. At the end of the day, I can't have this shape in Moto or any app. It has to go into a quad polygon, so I have to use my slicing tools to get us into the realm that I need to be. I can physically deform this shape. I can physically edit this shape into whatever it is that I need it to be a quad. Something like that. And now my mesh is now that one unique shape has been edited into a compliant shape for our rendering engine. It's now quad polygons. It's a shape that's made up of 4 four-sided surfaces. Okay. We're going to talk a lot about n-gons over the next 15 weeks, so we're going to come back to it. But just be aware that they're there, and this is the last surface type that we have access to. Okay. Let's go back to my teapot for a second and start talking about how we can work at this component level. We're going to use the exact same selection engine that we were working with at the item level, but let's extend this a little bit more because there's actually a whole lot of cool things that we can do with it. I want to be able to go in and very quickly select a huge spectrum of vertices along the outside of my teapot. Luckily for us, the guys down at Lexology have created a really neat selection engine that allows us to do this quickly. If I use the left mouse button, I can interactively select any one of my component types. Okay? Check this out. This is really kind of neat. What if I wanted to select a whole bunch of them? Well, if I left click and then drag, I'm dragging with my mouse cursor now, any vertice that I roll over is automatically going to be added to my selection. This is called the paint selection style, where if we just left click and drag, wherever our mouse cursor, or whatever our mouse cursor rolls over, it's going to be selected. Same goes with edges and polygons. So if I just click here, and I'm left clicking and dragging, and you can see wherever my mouse goes, I'm going to be selected. Or those polygons are going to be selected. Okay? What if? So how do I deselect something? Has anyone stumbled upon this? Yeah. Control click. How else? There's an easier way. Just click on the empty space in the scene, and that's going to deselect your guys. Check it out. I'm going to put my mouse cursor off of my teapot in the background of my OpenGL viewport and just simply left click. Boom. And it's going to drop the selection.
Make sure you don't have any tools selected when you do that.
Absolutely. Absolutely. Okay. Let's go back in and start talking about some of the other nuances inside the selection engine. I have three polygons on the outside of my teapot selected. What if I wanted to add a 4th, 5th, and 6th polygon into my selection? Now, my mouse cursor, or my mouse is up right now. I'm no longer left clicking and dragging, so that paint selection system is not accessible at the moment.
You can use the shift and arrow key.
Shift key. If you hold down the shift key, I can interactively add new polygons into my selection, or any of the component types. So the shift key, just like Photoshop, is going to allow us to add components into our selection. With that said, how do we subtract polygons from our selection? Control, just like Photoshop. So if I hold down the control key, I can take them away. Come on in, Abel. Find a chair. I think there's one in the back by Anthony. So shift will allow us to add polygons to our selection, and then the control key will allow us to subtract. Pretty neat. Pretty neat. Okay. Earlier, I mentioned that I wanted to go in and control the spout. I wanted to move this spout of my teapot around and create some sort of something else, okay? Well, there are a lot of polygons that represent the teapot or the spout of the teapot. I don't, if I wanted to move them all, I'd have to select them all, right? And there's just a bunch of them in here. There's got to be a faster way than doing what I'm doing here. Is there? Have you guys stumbled upon it yet? Double click, absolutely. Double click is going to select all the contiguous polygons, meaning all the polygons that are connected to each other, all the ones that are welded to each other. And I think this teapot serves as an excellent example of what we can do inside the computer graphics world. The teapot is actually a separate piece from the body. They're not connected to each other. Okay, this is cool. We're allowed to do this. Okay, double clicking will select all the contiguous polygons underneath your mouse cursor. For example, if I clicked on the base of the teapot, boom, you can see what I have. I click on the handle, boom, just the handle's been selected. So that's kind of nice. The same modifiers to our selection engine apply. So if I hold down the Shift key and double click on the base, what's going to happen? You got it. So Shift key, double click, bam, selects everything in the teapot. Shift key, double click on the spout, bam, it's going to select all the polygons that are connected to the spout. Okay. So if I didn't want like the base of my teapot selected, I could hold down the Control key and then double click, and it's going to deselect or subtract all of those polygons from my selection. Okay, pretty cool. All right. Questions so far? Yeah.
I think this might be a little, with the highlights, can you use the tools to completely move, like just say the handle? Could you use and rotate the handle on a different part of the pod?
Yes, absolutely. Moto has a really interesting and I think probably the best selection system in the world. They spent a lot of time engineering the selection system to make it work easily with the other tools. And here's the kind of the foundation of the entire tool system, selection system inside of Moto. If something is selected, in my case I had the spout and the handle selected, that's what's going to be edited. So that's what's going to be moved. I got my move tool going, and the only thing that's going to be moved is what's selected. Okay? So if I went and grabbed like the teapot, the base, and hit the R tool for scale, make it big and small, and that's the only part that's being changed. However, if nothing is selected, what's going to happen? Everything is going to be edited. Everything is going to be changed. So notice that I don't have anything selected within my scene, and if I activate the Move tool, the W key, the entirety of the teapot is being moved around my scene.
Which is important. Like if you have a whole scene and you don't select an item and you start moving stuff, you're just gonna move the whole scene.
Turns into a massive problem. So we gotta manage this, okay? If you want to move just the spout or just one specific thing within our scene, you gotta select it, okay? Because if it's not, everything in the scene is gonna be moved, okay? So if you want to see all your vertices on your screen, it's really easy. Just put your mouse cursor in the center of your OpenGL viewport and hit the O key, O for October. And then you're going to get this crazy little popover. This popover is going to control the shading and a number of the display properties for your viewport. And I've gone into the Active Meshes tab, and I've activated Show Vertices. So I can just turn it on and off. Woo. And I've made mine humongoid by activating the independent point size. That's the actual size that they normally show up on the screen. I've learned that it's good for me to make them big so the folks in the back can see what I'm clicking on. Yeah?
With this one, can you show which way the normals are facing?
Absolutely. Yeah. So if you go into Visibility, Show Selection Normals, You click on something, there it is. Yeah, click on a whole bunch of things, it'll show you. Pretty great. All right, other questions before we keep cruising? Yeah.
I pressed one of the shortcuts. I must have pressed it wrong. Does it turn my model black?
Turn your model black. Now you're working with something else. Hit undo. Command Z, not Control Z.
See, this is before it went black.
Yeah.
Why don't you go back into the, oh, let's see if it's,
Yeah, do me a favor. See where it says man, X, A, X, Y, Z? There's a little visibility icon next to that row. No, up here. You just click on that. There it is. It's a texture thing. Okay. Excuse me. Okay, so questions, other questions before we keep going? All right. Okay, so now that we have the idea of selections down a little bit, we have to start talking about how to work with our tools, okay? Now this is another kind of important idea that's systemic. The entire application works around this procedure for tools. Now we've been working with the move tool and the rotate tool and the scale tool, but we've turned them on, okay, and we've been using them, but let's talk about the kind of the relationship between the tools and the objects within our scene. So I'm going to grab the spout of my teapot just by double clicking on it, and I'm going to go over here to my toolbar and click on the move tool, okay? The moment I click on the move tool or hit the W key, we can see the tool handles pop up in the OpenGL viewport. This we know. But what if we're done with the move tool? What if we want to go on to something else? Spacebar, yeah, and you're right. We have to turn it off. Think of these tools like turning your car on and off, okay? To come to school, you jump in your car, the first thing you do, you turn it on, right? And then you use the tool to take you to the location, school. And then when you're done, once you're here, what do you got to do? Turn the car off, okay? So we turn on our tools, and then we turn off our tools, okay? I'm done with the move tool. I need to deactivate it. How do I do it?
you can hit the Q button as well.
You hit the Q button, okay? The Q button will work, but there's an easier way of doing it. Tap the space bar. Tap the space bar. It's going to drop the tool, okay? It's going to drop the tool. There it is, okay? Now, whenever a tool is active, you get a couple visual indicators and some nice reminders that you're currently using a tool. For example, I'm going to go back over and just activate the rotate tool, okay? Like everything in Moto, we're almost always going to get some tool handles. We can see that, but check it out. Over here on the left-hand side of the screen, below the toolbar, a number of tool options appear. So another strong visual example. So over here, another strong visual reminder that a tool is currently on and is being active and applied to the selections in our scene. So we've got tool options. The moment I drop the tool by tapping the space bar, two things disappear. The tool handle disappears, as does all the tool options on the left-hand side of the screen. Okay? So we turn our tools on, we turn our tools off. Tapping the spacebar, definitely the easiest way to drop your tool, to turn it off. It's not the only way. I think, Ray, you said hitting the Q key also deactivates the tool. In actuality, the Q key is not a deactivation of a tool. You're enabling the selection engine. That's kind of what you do when you hit the Q key. Okay? You can only ever have one tool working at any given time. So when you hit the Q key, you're actually going to the selection tool, okay? The other way to deactivate the tool, okay? Let me just zoom in over here. Now, do I have the move tool currently on and active? How do you know? Yeah, the background color of the tool has gone orange. Another nice visual indicator that the tool is on and working. If I was to click on that button again, I'd turn the tool off, okay? So clicking on the tool will activate it. it will also deactivate it. So it's now on, it's now off. Okay? Once the tool is off, it can no longer be applied to your scene, and it's not going to influence anything. So keep this in mind. Okay? This is going to be a little bit of a barrier for you guys as you start to work with these tools. Okay? Turn them on, you turn them off. Turn them on, turn them off. You often hear people out in the Motoverse refer to the deactivation of a tool as dropping the tool. Okay? So if you're looking at a forum, you're watching a video on YouTube, and someone says drop the tool, what they're talking about is the deactivation of that tool from your system. All right. Questions? We're all good? Really? All right, let's take a break. Let's go ahead and just take a small 5-minute break. Get up, stretch your legs, go to the bathroom. We'll continue this when we come back.